Hey, this is Mr. Mitchell with another video. Why don't you go ahead and write down the questions. Video today is on physical and chemical changes. And the first talk about the later talk about the changes, we'll talk about the physical properties as opposed to a physical change. They are interrelated. Physical properties are characteristics like color, shape, mass, that do not involve a change of substance. For example, a rubber band. A rubber band has a lot of elasticity. You can stretch a rubber band, but even if you stretch it completely out, it doesn't change what a rubber band is. It's a rubber band either stretched out or not stretched out. It's still a rubber band. So there are a lot of physical properties to any given substance. And one of the physical properties is called density. And the book likes to take this point in which to talk about density, so I will too, because it is a physical property. The relationship between mass and volume is called density. You can see the formula here. Density is mass over volume. It's the amount of matter present in the given volume of stuff. Heavier objects are going to be more dense. If you have a loaf of bread and a brick, the brick can be made to be about the same size as a small loaf of bread, but the brick's going to be way heavier and it will be more dense. Heavier objects are more dense. And you can see the formula is mass over volume. Now this is going to be in grams per centimeter cubed. Now you see that we have centimeter cubed here, but the totals we have here are in kilograms. So before we do any kind of computation, we'll have to change that to grams. Okay, for this computation, I happen to look up the density or the mass of a bowling ball. A 10-pound bowling ball is 4.5 kilograms, 14-pound bowling ball is 6.3 kilograms. And the volume of a bowling ball is about 6,250 centimeters cubed. Now, would the volume of a 10-pound bowling ball be different from the volume of a 14-pound? Not really. They're the same size. So volume just measures the amount of mass in it. So you'll have pretty much the same volume for a 10-pound as you would a 14-pound. So let's click my handy dandy calculator here. And we have 4.5 kilograms. That is 4,500 grams divided by 6,250 cubic centimeters. So you can see 0.72 is going to be the volume for a 10-pound bowling ball. Now looking back down here, we have the 6.3 kilograms. If we were to calculate that for a 14-pound, 6.3 kilograms is equal to 6,300 grams. So you were to divide that, and you know it'll be about 1 by 6,250 equals 1.008. So that's how you would calculate the density. And you can see what time of year I'm making this video, and I have no clue where Cupertino is, but it looks like it's about 79 degrees there. Well, I digress. Let's go back to here. So that tells you a little bit about density. You can believe we'll see more density in class. So physical properties like color, shape, mass, density do not involve a change of a substance. So you can rightfully guess what a chemical change is. It's some kind of change that does not involve a change of substance. And I've got this pretty looking little sheep here to show you an example. The sheep's wool, as if you didn't need an arrow there, changes a lot. It is on the sheep, then once it's sheared, it's off the sheep, then it's spun into yarn, then it's dyed whatever color the person wants it dyed, and then it is sold in a store to a person. But from sheep all the way through the process to person, it is still wool. It does not change substance. So all of these changes are physical changes, which leads us to chemical changes. We'll start out with chemical properties. You probably suspect that since physical properties did not involve a chemical change, chemical properties do. They have a change of substance. For example, here you have burning wood. All you'll have left at the end of all this burning is just ashes and stuff that has floated out into the air. Now, is that wood that has floated out into the air? Do you see little pieces of wood floating into the air? No. You have had a chemical change. It has actually changed the substance. The wood, after it's burned, is no longer wood. There'll be some kind of ashes, whether it's floating in the air or whether it's in the bottom of someone's fireplace. That is an example of a chemical change, burning. Another example of a chemical change, well, the chemical property would be, I guess, combustibility. Another example of a chemical change can involve an iron nail. Notice what's happening to this nail. It is rusting. The outside of this nail is actually changing from iron to rust. This is a chemical change. This is a chemical change. A tarnished spoon, and I don't have an example of a tarnished spoon here. The tarnish is kind of like the rust is here on this nail. It is has changed the original silver, I guess, in the case of the spoon. Here's one I did manage to get on here. You have these antacid tablets that you drop in the water. Now, what happens doesn't really happen to the water, it happens to these tablets. These tablets will end up completely dissolving, and they dissolve into these bubbles that are released, bubble all the way to the top, and they are released into the air. And it's actually carbon dioxide. That's CO2, and I was trying to draw that. So the chemical change is going from actually from a solid to a gas here, because these antacid is not carbon dioxide, but you have the chemical change when it goes with water to carbon dioxide. Another example of chemical change is digestion. We have the food that goes in our mouth, and it no longer is the food after a while. Eventually, it is the energy that we use to walk and talk and move and things like that. Now, sometimes it's not as easy to tell if a change is a physical change or a chemical change. So scientists have come up with several indicators that you might have some kind of chemical change going on. And sometimes in labs you have to really look carefully to see if there is some kind of chemical change or if any change is just physical. Some signs of chemical changes are a new odor. If you are mixing things together in a laboratory and you start smelling something, then that's a good sign you might have had a chemical change. Another sign that you've had a chemical change is that the temperature is different of the substances, and it's a common practice to check what the temperature of things are as you are mixing them together or as some kind of change is going about. Also, another indicator that you might have a chemical change is a change in color. Oh, this is a great example right here. We have this blue substance that's being poured into this beaker mixing up something else, and suddenly it's not blue anymore. I don't know if that is just some Photoshop work there or not, but if it's not, then you definitely have some kind of chemical change going on. This one, bubbles forming, hey, that happened when you had the antacid. Here the person shakes up the mixture and you have bubbles of some kind of gas which are forming. So that indicates that you might have a chemical change. And there's one final indication of chemical change is that a solid forms. Look in here, you had two liquids that are being mixed together, and at the bottom of the test tube you have a solid substance that is being formed. And that solid substance, you'll find out later, I guess you're finding it out now, is called a precipitate. So if you are mixing things together in a solid form, you probably have a chemical change going on. Well, I hope you've learned a little bit about physical and chemical changes.